This video is about calculating reacting masses involving limiting reactant. Generally, two or more reactants react to form one or more products in a reaction. The amount of the products formed may be limited by the amount of one of the reactants used. The reactant that is used up first and limits the amount of products formed in a reaction is called a limiting reactant. The reactant that is not completely used up in a reaction is called excess reactant. Now, let us use this example to see how to calculate reacting masses involving limiting reactant. In the extraction of lead from lead-2 oxide, 89.3 grams of lead-2 oxide is heated with 3.30 grams of carbon powder. What is the mass of lead formed? First, write the chemical equation for the reaction. After that, calculate the number of moles of each reactant. For lead-2 oxide, its number of moles is its mass, 89.3, divided by its molar mass, 223.2. That is 0.400 moles. For carbon, its number of moles is its mass, 3.30 divided by its molar mass, 12.0. That is 0.275 moles. Then calculate. If all of a reactant is used up, the number of moles of the other reactant that will be needed for complete reaction. In this example, if all of the lead-2 oxide, that is 0.400 moles, is used up, what is the number of moles of carbon that will be needed for a complete reaction? From the equation, the mole ratio of lead-2 oxide to carbon is 2 to 1. Therefore, 0.400 moles of lead-2 oxide requires 0.400 moles divided by 2, that is 0.200 moles of carbon for complete reaction. Since 0.275 moles of carbon is available, carbon is in excess, while lead-2 oxide is the limiting reactant. Finally, calculate the mass of the product formed according to the number of moles of the limiting reactant. From the equation, the mole ratio of lead-2 oxide to lead is 2 to 2, which can be simplified as 1 to 1. The number of moles of lead formed is 0.400 moles. Therefore, the mass of lead formed is its number of moles, 0.400 times its molar mass, 207.2. That is 82.9 grams.